Good morning, good afternoon, good evening, whichever time it is for you. We are going to look at Unit 1 Free Response Question Set B today for the solution here. The answers are on AP Classroom, and the grading is there. I will go through that as well. But there isn't any explanation of why they did what they did. So that's what this video is for, is to try and explain why the problem is solved the way that it is. Okay, hopefully you've read all of this part up here. This just kind of defines what it is that you need to show in terms of your work. If you haven't read that, pause the video and go ahead and read it right now. We're going to go ahead and start right here at this problem, which says, unless otherwise specified, the domain of the function f is assumed to be the set of real numbers x for which f of x is a real number. So domain, real numbers, answers are real numbers. And we have this piecewise defined function, this n of t. The number of fish in a pond at time t years is modeled by the function n, defined above, where f is a continuous function such that f of 0 is equal to 80. Okay, so a couple of things that I like to do when I do these problems is right away kind of mark up my function here. That n is the number of fish in the pond. T is time in years. Okay, now part A. Find the limit as t approaches infinity of n of t. Explain the meaning of that limit in the context of the problem. So, part A here. We want to find the limit as t approaches infinity of n of t. All right, so since n of t is a piecewise defined function, we need to look at the piece that talks about this as t approaches infinity. So clearly that's this section down here where t is greater than or equal to 8. So we are looking at finding the limit as t approaches infinity of 200 plus 80t over 2 plus 0.05t. To find a limit as t approaches infinity here, we can just take the fraction of the leading coefficients, since the degree of the numerator is exactly the same as the degree of the denominator. So this limit is 80 divided by 0.05. And no calculator is allowed for this question, so you would have to do this division on your own. I'm going to save us some time here. This is 1600. Okay, so what does this mean now? That is the limit part. What is the meaning of this in the context of the problem? This says as time goes on, n, the number of the fish in the pond, approaches 1600. So in the context of the problem, the number of fish in the pond will approach 1600 as time goes on. So you need to address both pieces. You need to address the numerical value, what the function addresses, and then you need to address that time piece, that time goes on. Okay, now part B says, is the function n continuous at t equals 8? All right, so in order to tell if a function is continuous, we need to compare the actual function value at that point versus the limit sorry, my watch is beeping. I'm just trying to shut it off, to put it on silent. Versus the limit as t approaches 8 of that function. All right, now because this is a piecewise defined function, we can go ahead and figure out this n of 8 by just plugging in 8 into whichever piece this was defined at. And n is 8 is defined right in here, so this would be 200 plus 80 times 8 divided by 2 plus 0.05 times 8. Let's see, up top, this is going to be 200, that's 640 here, plus 200, that's 840 over 2 plus. Now to multiply this, remember you're not going to have a calculator here, so let's just think about this. Just forget the decimals for a minute. This would be 5 times 8 would be 40, and then there's 2 total decimal places, so this would be 2 plus 0.4, or 840 divided by 2.4. Again, saving us some time here, I'm going to tell you that's 350. All right, that all is n of 8. Now, we do need to compare the limit from the left side of 8 and the limit from the right side of 8 in order to get this limit. So the limit as t approaches 8 from the left. Now, which piece is 8 from the left? Left side of 8 is this 25t plus 150 versus the limit as t approaches 8 from the right, which is that 200 plus, 80t, sorry, over 2 plus 0.05t. When we plug in here into the 8, this gives us 25, I'm sorry, into the t, 25 times 8 plus 150. 25 times 8 is 200 plus 150, 350. Okay, this one over here, plug in that 8, that's 200 plus 80 times 8 divided by 2 plus 0.05 times 8. Well, we just did that a couple of minutes ago. That was also 350. All right, score. All three of these came out to be exactly the same thing. So, yes, this function is continuous. Now, justify your answer. Your work is here, but you have to kind of tie it all together and clean it up at the end. So we will say, yes, n of t is continuous at t equals 8 because n of 8 is equal to the limit as t approaches 8 of n of t. This last bit in here is important because it's tying everything together and it's cleaning up your work, so that if the person who's reading your work doesn't know why you did it, you've just tied it all together for them. Okay, I am out of space here, so I'm going to go on to another sheet of paper for part C. If I turn that too fast, feel free to pause the video and go back and get that all down. All right, part C here now says the function n is continuous at n equals 6. Is there a time t for 0 less than or equal to t less than or equal to 6 at which n of t is equal to 250? Justify your answer. All right, so taking a look at this, let's see, we want to know, is there a place in between 0 and 6 that there are 250 fish in the pond? Well, over this time, let's look and see what's happening here. So at time 0, then n of 0 is equal to, well, if I go back, up here to my equation, 0 is going to be f of t. So this is f of 0. Oh, but wait, they told us that way back in the beginning. AP is famous for not giving you extra information, and they're pretty specific with their words. So everything that they give you in the problem is going to be used somewhere. So, and it's right here. F is a continuous function such that f of 0 is equal to 80. So right there, f of 0 is equal to 80. So we know n of 0 is equal to 80. How about at the end time? So at time equals 6, n of 6 equals, well, I'm just going to put a 6 in here. That's 25 times 6. Yeah, 25 times 6 plus 150. And 25 times 6 is 150 plus 150, which is 300. Okay, now, how are we going to tie this together? So, when you look at this, at time 0, there are 80 fish in the pond. At time 6, there are 300 fish in the pond. And we want to know, is there a time when there will be 250 fish in the pond? And the answer is yes, because that 250 is between 80 and 300, and this function n of t is continuous. It is continuous between 0 and 6 because f is continuous between 0 and 6. Then we know that that function n of t must take on every value in between 80 and 300. And that's it. And 250 is between 80 and 300. All right, let's write this out so that we can kind of tie it all together. Since 250 is between 80 and 300, and n of t is continuous on 0 up to 6, then n of t must take on every value between 80 and 300. That's it right there. But I'm going to add another bit in here. This is the intermediate value theorem. Okay, and aside, intermediate value theorem says if we have a continuous function on some interval from a to b, continuous function, that's the important part, continuous function, and if you choose some value k between those two given y values, f of a and f of b, then there must be some spot c in between a and b that produced that particular k value. So that's what this is saying. If we look at it, then this, like to this problem up here, that f of a, that's 80, f of b is 300, and your k value is 250. So the times here were 0 and 6. So if you choose any number in between 80 and 300, there must have been some number in between 0 and 6 that produced that particular 250 numerical value. Okay, hope that helps. I do want to take a minute now and go back over the scoring so that you can see how this would have been scored. If we look back to letter A was worth 2 points, letter B was worth 3 points, and letter C was worth only, where's my point value? 2. 2, 4, 5, 6. That's weird because most AP problems are 9 points, but maybe for these practice we're not making them out of 9. So part A, you will get a point for getting this 1600 right here. That gives you +1. And 1 point for the justification for this explanation. So if you'd make an arithmetic error in here, somewhere in here, you'd say you got 1600. Try again, 2000 instead of 1600. If you would not get this point, but if your explanation here was valid, you just had the wrong number here, then you will get this point. They don't play double jeopardy. All right, for part B, this was worth 3 points. You are getting 1 point for doing the limit as t approaches 8 from the left. So 1 point for that. You are getting 1 point for doing this limit as t approaches 8 from the right. And the third point comes from this explanation right in here, answer with reason. So they need to see a yes, but then they also need to see you tying this work together. So while you didn't specifically you don't get a point specifically for identifying this n of 8, you do need it when you pull it all together for that answer with reason. Again, if you made a mistake in the arithmetic and one of these came out to be, I don't know, say 400, you would not get this point. Say like this one you came up to be 400. You would not get this point. This one you would get, because if you got that one correct, and then if your answer said no, it's not continuous because these two are not equal to each other, then you would get the answer point. So again, they do follow through on your work. All right, and this one, part C, here's where the point values are here. This one gave us just 2 points. Where's my answer? Here it is. It was +1 for the answer with justification. And +1 to mention the intermediate value theorem. Now I will tell you this, on this particular practice AP problem, they do give you a separate point to mention the intermediate value theorem. On the actual AP, you don't need that. If you explain the intermediate value theorem clearly and you just don't mention it by title, you'll still get the point. I think they're putting this in here because these practice free response questions are very topic specific for a particular unit, a particular topic. When you take the actual AP test, the problems have parts A, B, C, D from many different units. So they only have 9 points to spread out. And so if you don't mention, they may put it in their answer key that it is an intermediate value theorem, but as long as you understand and clearly understand that you understand that concept, then you will get that answer point on the actual AP test. Okay, hopes this helps. See you soon. Bye.